Hi, I'm Alicia Lee, and today I'd like to talk about immunotherapy. Isn't it scary to think that every day we encounter billions of hostile germs such as bacteria and viruses? Thanks to groups of specialized cells, proteins, and organs that make up our immune system, we don't have to worry. But what happens when our immune system fails us? While our immune system is our guardian on the cellular level, it has been dubbed the double-edged sword. If its response is too weak, it is not able to recognize potential threats, and we may become susceptible to diseases as harmful as cancer. If its response is too strong, it attacks harmless organs or tissues, and we may develop allergies and autoimmune diseases like type 1 diabetes. Take cancer, for example. The immune system has a tough time targeting cancer cells because cancer starts as mutated cells multiplying out of control, which our immune systems don't always recognize as foreign. Sometimes the immune system may recognize the cancer cells, but its response might not be strong enough to destroy them. That's where immunotherapy comes in. Designed by scientists, immunotherapy stimulates your immune system to work harder or smarter to attack cancer cells. In the last few decades, immunotherapy has become important to treating certain types of cancer and autoimmune diseases. Compared to chemotherapy, immunotherapy tends to be more effective and has fewer side effects, so it will greatly contribute to how we treat diseases related to malfunctioned immune systems. One type of immunotherapy is monoclonal antibodies, which are man-made versions of antibodies. Antibodies are proteins made by B cells that circulate throughout the body. They latch onto specific proteins called antigens that are generated by harmful foreign intruders. Once the antibodies are attached to the antigens, they signal for other cells of the immune system to destroy the cells containing the antigen. In the lab, researchers can design and make many copies of antibodies that specifically target a certain antigen, such as those on cancer cells. Currently, monoclonal antibodies have been used to treat chronic lymphocytic leukemia, acute lymphocytic leukemia, and also autoimmune diseases such as lupus and rheumatoid arthritis. Adoptive cell therapy, or ACT, is another form of cutting-edge immunotherapy. In ACT, a patient's own immune cells like T cells can recognize and attack cancer cells, but are too few to succeed, so they are extracted from the patient and multiplied to billions in the lab. While in the lab, a patient's immune cells may even be genetically engineered to recognize and attack a specific cancer. These cells are then transplanted back into the patient. These methods are most effective for treating blood cancers such as leukemia. Immunotherapy has many other forms, and they can treat more than just cancer. Autoimmune disorders, organ transplantation complications, and infectious diseases like HIV and hepatitis can all be effectively treated by immunotherapy. As opposed to conventional treatments and drugs, immunotherapy is a revolutionary and rapidly growing medical field. Its applications in the future are very promising. I hope you've learned something today about the power and promise of immunotherapy. Thanks for watching!